Okay, so what we're going to be talking about today are the conventions of geometry. Obviously, you're in geometry class, so that's pretty simple. But what do I mean by conventions? Well, here are some conventions in real life. That one. Okay, so ask yourself, do I know these things? Do I know what the first one stands for? You're probably thinking Mr. When I put ASAP, what do I mean? As soon as possible. LOL, laugh out loud. What's the shape of the world? It's a sphere, right? How should you start a sentence? With a capital letter. How do you know what these things mean? It's because they are conventions. They're things that everybody has accepted. They're the accepted way things are done in a certain situation. Okay, when I put ASAP, people know that means as soon as possible. Okay, could I make up 4 words that go with that? Absolutely. But that's not the point. We are trying to do accepted conventions for everybody. The reason I bring this up is because in geometry, we have some things that are accepted, things you have to memorize in a sense, but you have to just know. You have to know those are the way things are done. Okay. First off, no assumptions. This is a really tough one because up until now, you've been allowed to make assumptions as much as you want. Basically, what that means, assumptions are a very bad thing to do in geometry. For example, when you look at these two shapes, which one's bigger? Which one's a larger triangle? Most of you are probably going to think the right side. I get that. But what if that left one is way off in the distance? What if it's far larger than the right one, but it's way back in the back? Okay, so what we don't do is we don't assume that size is relative. In this example, 7, 9, and 12, 60, 100, and 130. We don't assume that the shape is larger or smaller based on what appears. Okay, in addition to that, you should never assume that a picture is to scale. You could have one side that says 10 and another side that says 10, and they don't have to be necessarily the same exact size in the picture. As geometry teachers, we're not going to be measuring each angle we make on the computer. In addition to that, you're just not supposed to make assumptions like that unless you know it by measuring, in which case we'll say to measure it, because normally don't even bother measuring. You have to have the information. You have to be given the information. Before I gave you those numbers, you did not know which one had larger sides. Now you do. You can reason it out. Maybe that one's really close to the screen. The one on the left's way far in the back. But without that information, you cannot make that assumption. Okay, again, everything in geometry is based on evidence. This is important. You have to have a reason for everything you say. Okay, for example, what is the measure of that angle right there? Okay, how many of you are thinking 90 degrees? Probably a lot of you. But I didn't tell you it was 90 degrees. Until I give you the information, you do not know. So basically what I question is, what evidence do you have besides just your eyes, which may be very well tricking you if I didn't draw that picture to scale? You don't have any. You need something like a label. You need a little square in the corner, which tells you it's 90 degrees. You need the other angles so that you can figure out that angle. Okay, those are all pieces that you'll need. Okay, next up, some notation. There's a lot of parts of notation that are very important here. Some of this may not always be an issue. Some of it will always be an issue. But what we're going to talk about is some of the notation. Now, notation is the way you write things. It's basically a short way to write something. So we're going to start off with labeling a triangle A, B, and C. Again, in your notes, you're going to have to label some things. Most of the pictures are there. You're just going to be labeling and then continuing the notes. Okay? And the sides are A, B, and C. So, based on that, if I said, what do you think you know about the sides of a figure, of a triangle? What do you think the letters have to be written as? Is there anything important based on what you've seen? Okay, well, what you may have noticed is those are lowercase letters, whereas I used uppercase letters for my corners. And these are some of the conventions that you'll see very often. Capital letters are used for points. So even though they're corners, basically they're points in space. So corners that form the figure are going to be using capital letters. Lowercase letters are used for sides. So example here, A, B, and C. Also, you might have noticed that the B is opposite. The lowercase b is opposite the larger b. Same with A, and same with C. The lowercase letter is opposite the angle that goes with the uppercase letter that forms its point. Okay, now what we're going to look at is how to name angles. First of all, we need a definition. The angle is a turn or rotation that is created by two rays. So an angle is two rays connected together. It could also be a line, but when we look at it, we're starting from that point, so really it's a ray. From that point, it's a ray on. So it's a turn, a rotation from one ray to the next. The vertex, that's important. A vertex is the place at which two lines or line segments cross each other. In this case, Y is our vertex. Okay, naming an angle can be done in a lot of different ways, especially on this problem. First of all, if it's an angle like this and it's just one angle by itself, we could start out calling it something like XYZ. So example, starting with the first letter, X, then the vertex is always in the center, Y, and Z. Now the question you might ask yourself is, well, but why does it go XYZ? Could it have gone ZYX? Absolutely. You can go in either direction as long as the vertex of your point, which is Y, is the middle of the way you explain it down here. We could also call it angle Y. We're allowed to do that because there's only one angle and Y is the vertex. I could also call it angle 2 because inside here there's a 2 I've labeled. If you do not know the name of an angle, you can always put a number in there and use that. Or if it has numbers or letters, you can always use that as well. And the last one is ZYX, which is taking the same vertex, same 3 points, just writing them in a different order. These all describe the angle that is up there. So obviously, they all could be correct. Certain times, though, one is better than the other. So what we're going to say is it's best to use the 3 letters. If at all possible, use the 3-letter method. And the reason is this. If you have angles that are adjacent, meaning two angles that have the same ray. So in the center here, you can see we have QS, that's a ray. And that one is shared by two angles. The angle on the left, or the top, RQS, as well as SQT. So question is, what if I wanted to say, hey, I'm going to call this angle Q, the one I labeled in blue right there. That's my angle Q. What is the problem with doing that? So think about that for a second. Well, the issue is, how do I know that that's angle Q and not the other one? Okay, not this other angle. Or there's actually a third big angle there as well. How do I know which angle's which? So that is why it's so important to use the 3-letter method. Okay. In this case, if I use angle SQT, there is only one of those 3 possible angles that it can be. I could also use TQS. One is not more correct than the other. How many ways can we name different angles on this? And this is just an opportunity for you to kind of pause the video, think about it, and think of all the different angles that we could use 3 letters to name. So go ahead and do that for a second. Okay, so hopefully you've made your list. What I want you guys to do is bring that to class, and we'll kind of compare and see whoever was able to come up with the most ways to name angles, and we can have a nice debate about that. All right, so we can also be asked the measure of an angle. Basically what that is it's sort of asking you what are the degrees of the angle. So starting off here, if I want to know the measure of this angle, I will say M. So you notice there's that little M outside the symbol. What that means is I'm looking for the measure of JKL. This one happens to be 130 degrees. I don't know if that's drawn to scale, okay, but that sort of is what we could do. We could use a protractor to measure it or some other method. So the answer is 130 degrees. Okay, since it's over 90, it's also called an obtuse angle. That's something else that you should know that you're in geometry. Acute and obtuse. Okay, the second one here is another angle, and I'm going to ask, what's the measure of angle T? Again, I'm allowed to do that because there is only one angle, and I have T as the vertex. In this case, I have to give the information. It's 15, so therefore the measure is 15. This one's less than 90, so this is called an acute angle. Okay, the last one is a 90-degree angle, and you know that because of this little symbol right here. Okay, so FYI, yes, I played on words there, which again, you know what that means because of convention. This here is a 90-degree angle. That tells us that, so we know the measure is 90. Because this is equal to 90, that's called a right angle. So you need to be familiar with right angle, acute angle, and obtuse angle. Okay, the next page you'll notice there is already the circle drawn on there. Otherwise, we're going to draw the shapes. So first one we're going to talk about is a line segment. We're going to talk about what that looks like as well as how we write it. So first, it's written as something like this. AB with a line segment over it. What a line segment is it's just a line that has two endpoints, so they don't go on forever in either direction. In this case, they're A and B, so I'm written it as AB with a line over it. Basically, it's a line segment on top of it. The same is true for all of them. Next, we're going to look at a line. A line goes on forever in both directions with arrows, so when you write it with arrows on top. So it's basically a small line on top. And if you're going to use two letters to represent it, there'll be two dots on the line like that. Sometimes you'll also see that it can be represented with just one letter, like usually a lowercase letter that will be on the line. Next, array. Array, remember, has a point on one end and an arrow on the other, so as you can imagine, that's what ends up on top of the two letters. And one of them will always be the endpoint. My interpretation is you should start your naming of it with the endpoint, not the arrow that goes on forever, but I'm not sure that that's something that everyone has to follow as far as a convention goes. I think you can write it either way. Next, we have an arc. Okay, so if you notice on your paper, you're going to have, on your paper, it doesn't have that nice blue thing on there. It's marked literally with a little arc. Usually what you need is 2 points, and the arc will connect those 2 points. Your question might ask is, why is that TY and not the other one TY? Well, that's why we usually talk about the smaller arc, the minor arc. Usually what I've seen is if they're going for the big one, they'll put another point down in there so you can kind of see TXY or whatever. And circle. In order to write a circle, you could always write circle Q, but it's written as the center. So in this case, we're going to add that point Q into the center, and then now we can name it. You can write the word circle, or an abbreviation they use is they actually have like a little circle with a dot in the center of it. So you'll see these things, and you need you to be able to go back, look at this, and say, oh, what does that mean again? Oh, that means a line segment. A lot of times that AB at the very top, that line segment, that'll represent like a side of a triangle. So if a triangle has AB, you'll say that AB, and that'll tell you that you're talking about a side. All right. Next thing we're going to talk about is parallel lines. Okay, first of all, the symbol for parallel looks like two long L's. This is an interesting one because when I was in high school, I never learned this, and so when I took the test, I had no clue what it means. So here's an example of parallel lines. So as you can see from the picture, it kind of looks like two parallel lines. They're lined up and they're going with each other like L's would. So now here, each line has been labeled with a single letter, M and N lowercase, because it's almost like a side. Okay, now to say those are parallel, all I'm going to do is I'm going to put M is parallel to N. So you can kind of see it doesn't quite, it's almost like in between, but then also down a little bit. So it looks a little different than two L's do. If we want to add a second set, we can just use more than one arrow. As you noticed on here, we have these arrows, and what those arrows do is tell you that those lines are parallel. So if I add a second set, I might put two sets of arrows on there to tell me that those two lines are parallel to each other. Notice here I have F and E as my lines. Now we're going to talk about perpendicular. Perpendicular lines are lines that meet each other at a 90-degree angle. So, as you might imagine, that's the symbol. Okay, they didn't use a T for obvious reasons to be confusing. They use an upside-down T to represent perpendicular. And two perpendicular lines meet at a 90-degree angle. In this case, it would be C perpendicular to D. Okay, so we're going to talk a little bit about similarity and congruence. Similar means two things are the same shape, but not always the same size. This is important. Congruent, however, means something different. The notation we use for similar is sort of this squiggly line. It's not even squiggly. It's like a little bit of a wavy line. That means similar. Congruent means two things are the same size, and also they are the same shape. So when I look at the symbol, I see an equal sign with the similar symbol on top. So similar shape, it comes from the similar sign, the wavy line, and the same size, meaning equal size, is the equal sign. So I like to look at congruent as equal plus similar, basically. So equal size and similar. Because if you think about something like a rectangle, you could have two rectangles that have the same area, but they could be different shapes. So congruent rectangles will have the same size and the same shape, which means they're basically completely the same. So equal parts of a figure are marked. So here's how we mark them. So first of all, label your triangles. The way they mark them, so if I want to say, hey, this side and this side are equal, they'll use like one dash mark, as I've done here. If I then want to say two other sides are equal, I have to use two dash marks, because if I just use one again, how am I going to know which one I'm talking about? For me, obviously, I could use color, but when you're on your paper, you're not going to be writing with 15 colored pencils. And you can't expect everybody to see that too. So, some people see different colors. Some people are going to see black and white when you copy it or print it. And most of the time, let's be real, you're writing in a pen or a pencil. So we don't have that luxury. So what we're going to do is we're going to go ahead and use 2 to represent a pair that's the same. And if we wanted to do a third, we could use 3 sides as well. So now for angles, they use those arches. So if I do that and that, I'm going to say those two are the same. I could then also use double arches for a different one. Sometimes you'll also see that in the middle of the arch, they'll just put a line, just like we do on the side. So 1 line, 2 lines, 3. I don't like doing that too much because it's very easy to spread out 2 marks, 3 marks, 4 marks. But when you're in this tiny little angle, there's not enough room to make 4 little marks in there. Okay, so now what I could do is if I want to write this, I could say, okay, AB is congruent. That's what that symbol means, congruent to OF. Okay, and you want to get that word congruent into your vocabulary. Also, CA is congruent to SO. They both have the purple mark. Angle O on the right triangle is the same as angle A on the left. And angle C is the same, congruent as angle S, which means it's the same size and the same shape. Okay, so this is the end of our notes. Down below the video, you'll notice that there's a little form to fill out. If you did notes with me in class, and you already have them completed and everything like that, and you just happen to go back and watch this, you don't need to fill out the form again. But if someone comes to our class late, or for the following year, if this is the first time you've seen this video, then you definitely need to fill out the form below. That's my way of checking in and knowing that you've watched it. So I will see you in class soon. Bye.